so continuing our examples of graph transformations, we've got a graph here that's actually pretty complicated. It looks like it's got all of the different components for a transformation, all 4 of the elements. So this one will be a little more challenging than the others have been. The first thing that you want to take note of is that we've got a 4 in front, and to rewrite that, technically you would usually see that on the back side as a +4. So as I rearrange that, I'm going to move that to the other side. So I'm going to rewrite this as y equals -2 sine of factor the 3 out of the parentheses and divide both of those items by 3. So we'll end up with pi over 6. And then, like I said before, that +4 is going to come onto the back. Both of the items that are inside the parentheses are going to be related to our x values. So this is going to change the period to 2 pi over 3. And this is going to shift the graph to the right by pi over 6. And then both of the terms that are on the outside of the parentheses relate to the y values. And so we'll have those relating to y. This is going to shift the graph up by 4 units. And this is going to be a change in the amplitude. The amplitude is equal to 2. And then we also have a reflection across the x-axis. Even though that is working on the y value, it's moving it up down, so that's why it's reflecting across the x-axis. Okay, so let's take these sort of one at a time. Let's start with our x values. So within our x values, and I kind of will go left to right. I'm going to look at the 3 first before I look at the pi over 6. So I'm going to break the period up starting at 0, going to 2 pi over 3 as my ending point. We have pi over 3 in the middle, and then we'll break each of those intervals in half. So that'll be pi over 6, and then the halfway point between these two is pi over 2. Again, the way that you can find that is if you take 2 of the components, pi over 3 plus 2 pi over 3, and then divide by 2. That'll give you the average. It'll give you that value that's in the middle. When I type it into the calculator, I don't have the pi symbols. I just use the fractions. All right, and then because we've got that phase shift to consider, we're going to add pi over 6 to each of these values. And so we're going to end up with pi over 6 as our starting point, and then actually, hang on. Yeah, and then this will be pi over 3, and then that's 2/6 plus 1/6. I think this is pi over 2, and then I've got 1/2 plus 1/6. Which is 2 pi over 3, and then the 2/3 plus 1/6 is 5 pi over 6. Okay, so these are the x values that I'm going to be plotting. Let me just highlight those. And then we'll shift to the y values. Our original graph is sine, and sine typically starts with the center of the graph, or the midline, going up to the max, back to the midline, down to the minimum, and then up to the back to the midline. which is 0 at the midline, 1 for the max, and -1 for the min. But what we're going to do is we're going to reflect and amplify at the same time. So we're going to multiply each of those values by -2. So we end up with the zeros stay the same. This maximum point changes to a minimum, and this minimum changes to a maximum. So these are the y values that we're going to end up plotting. So we have pi over 6, 0, pi over 3, -2, pi over 2, 0, 2 pi over 3, 2, and 5 pi over 6, 0. So let's put all those together. It looks like we're going to make the tick marks on our x-axis be by sixths. I'm going to have my max and min points be at 2 and -2. Let's see, 1, 2, 3. I'm going to put 2 up here. I'm going to put -2 down here. And then I'm going to just count off 1/6, 2/6, 3/6, 4, 5. 5 pi over 6 is here. Right. So putting my graph together, I'm starting at pi over 6, which is at the midline, going up to the max. Oh no, going down to the min, back to the midline, up to the max, and then back down to the mid. So my graph, as you can see, it's upside down from a normal sine graph. The amplitude has been stretched to 2 and -2, and then the whole graph has been shifted over to the right by pi over 6. I wanted to do one example that has a tangent in it, and this is a good example. It's got a couple different components. Let's rewrite this before we get started. We'll factor the 4 out, and then we'll have the -2 on the end. This is going to be a vertical stretch. Remember that we don't really have amplitude in the tangent graph, so it's just going to grab the quarter points and stretch them. This is going to change the period. The period for tangent is normally pi, so we're going to divide it by the number. It'll be pi over 4. Everything is going to shift to the right by pi over 4. And then everything is going to go down by 2. Okay. So let's start with our x values. The period is pi over 4. So what I'm going to do is I'm going to take pi over 4 is going to be split in half. So if I think about a length of pi over 4, cutting that in half, I would have pi over 8 on both sides. And the reason that's important is because the tangent graph is, the middle of it has to be in the center. It's going to straddle the y-axis on either side. So I'm going to go to -pi over 8 to start and positive pi over 8 for my ending. 0 in the middle, and then split these in half. So this will be -pi over 16, and this will be positive pi over 16. So I want that total distance between the beginning and the end to be pi over 4, which is the period, and I split it in half so that 0 is in the middle. So that's taking the period into account. But then what I need to do is I need to shift everything to the right by pi over 4. So I'm going to add pi over 4 to each of those values. So we'll have, let's see, -1/8 plus 1/4 is 1/8. This will be pi over 8 plus 1 is 3 pi over 16, pi over 4, 1 over 16 plus 1/4 is 5 pi over 16, and then 1/8 plus 1/4 is 3 pi over 8. So these are the x values that we're going to consider. And then looking at our y values, we have, normally we have an asymptote. We are at -1, 0, and 1, but we're going to take that vertical stretch into account. So we're going to multiply by 5. So this will change to -5, 0, and 5. This is still going to be an asymptote here. And then the second thing we'll do is we'll subtract 2 from each of those values. So then what we're going to do is subtract 2. So we're ending up still with an asymptote. This is going to go down to -7. This will be -2. And this will be 3. So these are the y values that we're going to end up plotting. Okay. So I'm going to start at pi over 8. Let's draw my y-axis here. Let's start at pi over 8. And this will be an asymptote to start. And then we're going to go, that's 1, 2, 3, 4, 5, 6, 7, 8. Hang on, let me just pause this video for a second. Okay, I just had to pause because I had to do a couple calculations and I don't want to lose the amount of time that I have. So we're going to count off by 16ths, which is the lowest common denominator here. So pi over 8 is the same as 2 pi over 16. So I want to count by 16ths. So I'm going to skip every other line here, every other dot that I have. So I'm going to have, this will be 1/16, and then 2/16 will be here, pi over 8, and that's going to be my asymptote. And then I'll have, that's 3/8, 4/8. 4/8 is, or 4/16, sorry, is the same as pi over 4. So that's the middle of my graph here, pi over 4. And then we'll have 5 over 16, and then 6 over 16, which is 3/8, and that's our other asymptote. And then I've got my points. I've got -7 at my quarter point here. So let's see, 1, 2, 3, 4, 5, 6, 7. It's way down here. In the middle of my graph, I'm at -2, which it looks like is around here. And then the other quarter point, I'm at +3. So 1, 2, 3, so somewhere up here. So my graph is going to look like this, going towards that asymptote and then coming back down to the other asymptote. All right, I've got one more example to do. So thanks for, sorry for the weird thing that happened in the middle.